In April 2025, X-Rite hosted our first AXF User Summit in Stuttgart. AXF Appearance Exchange Format users came together to share their experiences and learn how to support and accelerate their product developments.
We are from the visualization department. We have not only the TAC7, we also have the MAT12. Creation of materials and colors became very easy and repeatable and reliable. So what we had then when we did this kind of update was really a portal between the physical and the digital world.
90% more of what consumers see across every touch point was never done with an actual product. Everything that you see there, everything consumers will see, is being digitally replaced using a digital twin 3D model. Yeah? So, and again, right, this has always been about photorealism. When you talk about replacing products, especially in marketing assets, what you are chasing always is photorealistic output.
Comes the digitizing process. In 2019, we purchased TAC7, and then last year we were happy to buy some more equipment. So we got the CI7 and the MAT12, and we use MAT12 mostly for metallics and solid colors, so like solid, non-transparent colors. And the CI7 comes as a best solution for mirror-like materials. Whereas I would say TAC7 is still an overall best solution when it comes to the complete library. And this gives us two directions to work in. So one is in-house with our designers who work in KeyShot, and you saw this render yesterday in KeyShot's presentation, where they do the product development directly with AXFs, knowing that this will for sure look like in the manufacturing as well. And the other direction is the marketing production that David will talk about a bit further, and that we do with external suppliers.
This is the 2019 benchmark image that we created. That was actually what brought the AXF TAC7 scanner into Philips. So we ran this pilot with X-Rite, and we use this comparison. This was shot by a product photographer on a studio. It took almost 4 hours to obtain that single image. And the AXF, they really allowed us to scale up our pipelines.
What happens next in our backend system? We're seeing a sample request coming in to our sample management tool. And just remember, we have 6 sites globally. So everything has to contribute. So it's a little bit of a bigger challenge if you have to organize this orchestra. So they are grabbing a measurement shop from that software. And then we're pulling data from our ERP system, and we're creating an XML file, which we then use in the Pantora software. So basically, this XML file is ending up as metadata. So when you create the measurement, we get an AXF file, which already has an address, so it knows where it belongs to. And later, when we have that AXF file, we're uploading it back to the system. We're sending it to our high-performance cluster, where we're creating these preview images. And at the same end, it becomes available in our systems. And customers come to us with a kind of color specification that we need to understand. And we create a recipe. So putting things into rendering applications, doing digital twin of the materials, that is really helping us to create virtual prototypes that are making sense for the design community. So first of all, we need to connect that somehow to our existing world. So that's one way of creating digital samples.
So what can we provide? We provide, of course, AXF files. That can be SVB RDF scans, but also auto scans for metallics. We have all of our stock products scanned with our TAC7 scanner. So what can we provide? We provide, of course, AXF files. That can be SVBRDF scans, but also auto scans for metallics. As well as product visualizations. These visualizations are, of course, also used within our online shop just to give a demonstration of how our colors could look. You're faster. You're more flexible. You can try out things. You do not have to wait for physical samples to be shipped to your locations. You are always well informed. You have an imagination of what you are designing and producing. So you don't have to wait for a physical prototype to come up. And what is that at the end? You're more efficient. Time is money. All of that stuff covered.
Increasing the concentration of crystal glass pigments. So with 0%, so we're slowly increasing it, and you can see the amount of visibility that you can get. So this is not only for human vision, for camera vision, but also for LiDAR visibility, for example. Yeah, for helping everyone to be seen.
My name is Mike Weiss. I'm a senior solution architect at Epic, so I help folks like you use systems like this. One of the big enablers for the AXF project that we're doing in conjunction with X-Rite is substrate. That's what enables this. That thickness and transmission, each of those layers has a physical thickness that you can define, really allows us to start to look at these coats in a way that's physically based. So X-Rite knows color like nobody else, right? So they're doing the logic of how they feel these parameters should be transmitted to Unreal Engine. And so with the combination of the standard JSON format and the EXR format that's adopted everywhere, that package comes out, and then there's a plugin in Unreal where you can just bring it in. And basically, I have my materials, I drop them on my object, and here we can see I've got a little rotator so we can see it go. Some of you saw it yesterday when I was running it in the lobby. Neat, right?
I've just made a big point of saying just how difficult it is to create all these like marketing material. So here is where visualization, where 3D rendering comes in, as opposed to producing physical prototypes. This is where they saved 4 months in a typical product cycle, in a product design cycle. I really think it's crucial to also highlight how easy it is to apply an AXF material. Just simply going in, scrolling our material library to measured materials. These are actually, a couple that come with, I'll talk more about more materials, and simply dragging them on a object, right? In this case, obviously, as you can see, our helmet. And it just being that simple to generate images is super powerful.
What we're going to talk about is agnostic spectral rendering using Predict Engine. So the idea behind this is that we bridge really the gap between the world of designers and the world of optical engineers using parameters from the spectral world for polarization. We use material properties. Of course, we're here, so we support AXF, and I'll dive a bit more into it. But what is important to see here is that everything is characterized in order to provide a single source of truth for designers to do beautiful images, to do some realistic images. But you can also do some false colors validation based on spectral measures and based on measurement for the entire environment. And I'm specifying this because we have a suite of products. The main one being, of course, Predict Engine, which is the render engine. It's a spectral renderer, and I'm putting the emphasis on spectral because here we use the spectral information natively within the rendering, which is a big deal for us because there are a lot of problematics for the industry because they need the spectral information to validate.
All right, we've just seen a material that we can neither properly measure nor render yet. And now I'm going to talk about how awesome our rendering is, so thanks. Anyway, so my presentation is about how we use AXF measured materials as integral part of our rendering pipeline to be as physically accurate as we possibly can. And maybe to introduce myself, my name is Martin. I work in the CATIA R&D. I work as a portfolio manager, and I'm in charge of our visualization and rendering portfolio. So in a nutshell, What we provide to our customers is tools for visualizing your product properly. We heard the term virtual twin yesterday a couple of times. To us, it means a bit more than just what it looks like. To us, a virtual twin is, since we are CATIA, we are part of this whole ecosystem with mechanical behaviors and harness wiring and simulation of all sorts. When we talk about a virtual twin, to us, it's what it looks like, but also how it behaves, how the product itself functions, and also how the product integrates with its environment. As mentioned earlier, we support IES profiles, light distribution, and do all sorts of quantitative analysis for how light works in your scene. And last but not least, our camera model mimics human eye physiology, and you may know the way our receptors work. For example, in low light conditions, we don't see colors the same way. We tend to see them less saturated and more contrast. And also because of the color values, like a red or a blue will be perceived very differently in terms of brightness. So what that looks like is we have our exact geometry, native CATIA model. We have our measured materials on them, and we put them into a measured environment.
And this material representation, this shader they used was the so-called bidirectional texture function, the BTF. And here are some nice renderings from that time, right? Nice velvet, car paint, 3D textile. These materials, I mean, at the time they were difficult to create with your standard texture-based workflow. So, and in contrast to the showcase integration, the dome produced files which could already be loaded by a few important software packages like VRED, DeltaGen, and we had this plug-in for Mentoray at V-Ray. And then a 2-year learning period passed by, and AXF 1.0 was born. And then one level further, we have something we could call appearance traits, keys, factors. That's something like the texture scale, a gloss unit, a roughness factor, or something like this. So parameters you would use, for example, to rank, to compare your materials, stuff like this, right? Apply a metric or something.
In some examples, there are also possibilities that just spectral data isn't enough to judge the full quality of a material. And that's where we want to go now in a next step is we want to use our existing devices and we want to use the data we get from the appearance to combine that into each other into what we will call appearance quality control, to take all the information, is it the roughness, is it the gloss, and so on, to see can we put a number behind to make sure it's measurable what we see and it's controllable as good as possible. My first example would be for exterior paints. Victor and you all can tell me a bit more about that. Parts or car will not be produced in one place anymore. The door comes from Turkey, the hood comes from Czech Republic, and will be only assembled at the final destination. But we need to control before if the door, if the hood, if the mirror matches with each other before we even can get hold of the material. We want to look at exterior paints. We want to also look into plastics or any structured materials. But here we have the same problem. Materials comes from different places. Material have different structures, will be visualized or controlled under different conditions. And here even worse, we have different devices we are checking. We have gloss meters. We have instruments with 450 or sphere instruments. So every supplier, every customer have different quality control processes. So we have a huge variety of data we need to bring together and control them ideally.
My goal today is to give you a demo of the Pantora software. How many people have actually played with our software? actually look at metameric materials. So I've got, which will allow us to look at materials side by side. Garo spoke about this a little bit in his presentation. So our D65 lighting indicator, which is used to evaluate in our light booth, we can actually also do this inside of Pantora. So I've now moved to a point light system, which allows us to then change our lighting. So I can change to a tungsten, and then I can start to see differences in color, so it's much lighter and doesn't match where this is intended to show us D65. So I come back, and then we can see the differences with that as well. So, whoops.
Let's pick up where we left. So that was the last slide of my previous presentation of the retrospective. And we had the question mark. Where are we going next? So, yeah, a few topics. At least 4 different tracks I'm currently seeing. So we have first extending and improving the visualization software support of AXF, right? Here I would also like to talk a little bit about material appearance standards in rendering industry and how this could relate to AXF in the future. Another quite interesting topic is the introduction of supporting non-X-Rite devices in the ecosystem. I will give also a bit of background on what we call the evolution of appearance. How do we manage appearance across the supply chain? And I think there's also connection to the introduction of this whole-point device here, the topic of appearance QC.
We are producing an instrument, we could call it, a tool that you can use for making AXF a bit better for the next future to come. So our idea was to create one tool for it all, for most of the tasks that you actually have. The tool, the aesthetics, is a dual camera-based device, means it can deliver HDR images that are topographic and dimensionally correct, first of all, and it provides solutions for almost any kind of the issues that we actually have in QC. It was developed together during a PhD study with the KU Leuven in Belgium, and this study was focusing on the effects of glossiness. So, as you can see here in the image, what we actually have are 2 CMOS cameras with a pretty high resolution of 10 micrometer per pixel under 0 degree and under 60 degree, because the work started off as measuring gloss 2D apart from a single value. During the work, it became observed that there are a lot of things you can actually measure if you add more than one illumination to it, and this is the reason why we have not only a gloss light source, but we also have a spotlight source under 10 degree, or a line light of 20 millimeters under 15 degree, plus 450 LEDs around the normal. So what can you do with it? The thing is, almost everything. Yeah. So, but you can only, in terms of QCing, purchase what you need. That is the next thing. Keep your invest low in order to have a tool and for the task that you need it. So we have split it into certain tasks that you are doing in QC, which means that you have a module for surface brilliance, as we call it, that has everything to do with gloss. So gloss is not only glossiness as a value, as we have heard today as well, but there are more things behind that, like haze, sharpness of a reflected image, waviness that you actually have on the surface, plus what we call the perceived gloss. I'm coming to that later. You can measure sparkling with it. You can measure polishing quality in terms of defects of the surface. You can also measure, if you're more technical, this goes more to the technical side, you have the cross-cut adhesion, plus if you're more into...
The idea is, how can we now bring that together with spectral color? Because we learned spectral color is super important for quality control and doing correct lighting simulation. And for that, I want to use now, I want to show you now how to do that with the variant editor, very similar to what Thomas already showed earlier. But just to point out, we can get the spectral color information we can get from multiple sources. We can import it from CXF files we get from color libraries, and we can use it, can connect any of these devices that are supported by Pantora, or we can measure to a CXF with these X-Rite devices.
I really want this to be the community, because without it, AXF has no value. It's all about how we've actually created that partnership.